Okay, stats. Chapter 6 test day is tomorrow. I'm going to run through the Chapter 6 review with you real quick just to kind of make sure that you check your answers. Everything is good on your review. I am going to let you use this review and your formula sheet on your test. So, yay. Make sure you have your review all filled out, ready to go, and your formula sheet as well. So you can use those guys on your test. Let's get started with number 1. So I have this drawing for number 1 already filled out, and they're wanting to know if I am given the z-scores that are negative 2.41 and 0, what percent lies in between those two. So we've kind of drawn the picture already. 0, we don't necessarily have to even look up on the chart because we know, or should know, that everything to the left of 0 or everything to the right of 0 is 50%. Okay, so 0.5000 as a decimal. And then we are going to look up negative 2.41 on the chart, and that is, I gotta get my chart here, negative 2.41 is 0.0080. 0.0080. So if I subtract those two, then that means that 4920 or 49.2% of the scores are going to live between those two values. Okay. Number 2, we've already set up our bell curve as well. This one is asking for a z-score that's greater than 0.97. So we mark off 0.97. We want greater than. I look up 0.97 on my chart, and it's on the positive table. 0.97 is 0.8340. 0.8340, except 0.8340 is going to go to the left, so you need to subtract that from 100%. So 0.1660 or 16.6% is going to be to the right of a z-score of 0.97. Okay. Number 3. Find the area of the shaded region. The shaded region is everything above negative 1.82, okay? They label positive 1.82 for some reason. I don't know why they do that. We don't really even care about the positive 1.82, just everything above negative 1.82. So we're looking on our chart at the negative table. Negative 1.82 is 0.0344, but that's going to tell me from here on back. 0.0344, and so I want everything to the right of that, so I'm going to subtract that from 100%, which would be 0.96, I'm blanking here, 56, I don't know if that's necessarily right, 0.9656, yeah, that's right, or 96.56%. I don't care how you write it. That's how much of the data will be to the right side of that. And when you're doing these, this should kind of represent, like, the shaded region is the area there that I'm looking for, and that looks about 96% of the area. The part that's not is that 3%. So make sure that your areas kind of correspond to, like, what's shaded in. Does it look like it's 96%? Next 3 problems are all from section 6.2. I think, yep, section 6.2. The lengths of human pregnancies are normally distributed with a mean of 268. Anytime they say that, write it down. Mu is 268. Standard deviation is 15. Write it down. What is the probability that a pregnancy lasts at least 300 days? At least 300 days. Okay, so average is 268. At least 300 days means 300 days or more. So I'm looking for this area inside of here. And all we need to do is convert to a z-score. So z is x minus mu divided by the standard deviation. 300 minus 268 divided by 15. And I got to get that written down. 300 minus 268 divided by 15. 2.13 is what he has rounded. If I look that up on my positive table, 2.13 is 0.9834. But that's from here this way, 0.9834. So, like 1.66% is what that's going to be to the right side of that. Okay. Now, I had a lot of people asking me, do I need to use, like, let's see, 299.5? Is that the one where I use 299.5? You would use 299.5 if this was a binomial distribution, like we did in section 6.6. Okay, and we'll see some of those. So like when we had 43 boys, we would do like 42.5 or 43.5. Okay, that's if it's a binomial distribution. This one is not binomial. Okay, there's not two decisions. We're talking about the length of a pregnancy that doesn't have two decisions. That's not binomial. Okay, so just kind of remember those key elements. And that will tell you kind of how you set your problem up, okay? Number 5, scores on a test are normally distributed with a mean of 63.2, standard deviation of 11.7, and they want us to find P81, okay? Here's 0 in the middle. P81 means the 81st percentile. That means everybody below me is 81%, so 81% of people are below me, 19% of people are above me. We don't care about this 19% because the way that we read our table is backwards, okay, or is to the left, okay? 81%, this is going to be looked up in the table backwards, so you're looking at the inside of the table and you're trying to find the z-score. So the closest number to 0.8100 is 0.8106, which is located at 0.88 as a z-score. So we're looking up in the inside of the table, 0.88. And then they actually want to know what test score that is, okay? So I am finding, I know the z, x minus mu divided by the standard deviation. I know this. I'm trying to find the x. So 0.88 equals x minus the average is 63.2. Standard deviation is 11.7. So you're going to multiply by 11.7. And then you'll add this 63.2 to that. Okay, and that will give you your x. I'm going through this kind of fast because you should already have this done probably. 0.88 times 11.7 and then plus 63.2. And I got 73.5-ish. That's what he should be. Okay, number 6, they want us to find P60. My average is 200. Standard deviation is 50. Write those guys down. P60, this is the same type of problem. Here's 0. That means the 60th percentile, 0.6000, is to the left of me. We really don't care about the top 40%. Great, this is 40%, but we really don't care about that. It's all everything to the left. This is another backwards look up in the table. So closest number to 0.6000 is actually the 0.5987 number, which is 0.25. So this z-score is 0.25, just like we did up here. We're going to say 0.25 is equal to x is what I'm solving for, minus 200 divided by 50. Okay, and I'm going to multiply 50 across, and I'm going to add the 200 over, and I'm pretty sure I remember the answer to this. It's like 212.5, I think is what it is. Okay, all right, number 7. A study of the amount of time it takes a mechanic to rebuild the transmission for a 2010 Chevy Colorado shows that the mean is 8.4. Write that down. Standard deviation is 1.8. If 40 mechanics, okay, N is 40. This is a really big deal. This is section 6.4. We're not talking about one person. We're talking about 40 of them now. So this is where we have to calculate a new standard deviation. New standard deviation is the old standard deviation just divided by the square root of n, okay? And that's the tricky part to this, all right? Find the probability that their mean rebuild time is less than 8.9. So we've drawn our bell curve. 8.4 is the middle. I want to know to the left. But I need to find the z-score for this guy. And it's x minus mu divided by the standard deviation. So x is 8.9 minus 8.4, but I have to divide by the standard deviation, which is not 1.8 anymore. It's 1.8 divided by the square root of 40. Okay, so give me just a second to do this. 1.8 divided by 40 square root, enter. 0.2845, let's go. Okay, so 8.9 minus 8.4 divided by 0.285, and that is a z-score of 1.75. Okay, then I want to look up to the left of that, so in my positive table, 1.75 is 0.9599. 0.9599, or 95.99% of my data is going to be or 95.99% of the time it's going to be less than 8.9 hours. Okay. All right, number 8 we did together. If you want to take a look at that, pause this video and you can see we've got 5.77 as our percentage. Number 9 we kind of did together on our formula sheet. If it's at least 12, then the number we're going to use, at least 12, means 12 and beyond, so we're actually going to use 11.5. Okay, so our continuity correction factor is actually 11.5. That's the number that we're going to use. At most 12 means 12 and less than, but we want to include 12. So I'm going to use 12.5 as my number. Okay, more than 12 means not including 12. So we want to go from here this way, which is 12.5. So that guy that we're going to use is 12.5. Less than 12 means not including 12, so we're going to use 11.5. So 11.5 is my number that I'm going to use for that. Okay. Number 10, for the binomial distribution with n is 24, p is 0.6, state whether or not it is suitable to use a normal distribution as an approximation. This is just a yes or no question. So we take n times p, which is 24 times 0.6. 24 times 0.6, and that is 14.4. Okay, then I take n times q, and if 0.6 is p, q is 0.4, I multiply those together, and I get 9.6. And both of those numbers are greater than 5, so yes, you can use normal distribution. Okay? It's totally legal, and that's all they wanted for number 10. Number 11, we've already done as well. The given values are discrete. Use the continuity correction and describe the region of the normal distribution that corresponds to the indicated probability. Exactly 44 green marbles. Okay, if I'm doing finding the continuity correction for exactly, this is kind of a pain in the butt, 44, we have to have a range for when we do exactly. So I have to have two numbers that I'm going in between, which is 43.3 and 43.5 and 44.5. And those two values I'm going to go between. So all it was saying was describe the region. This is my description of the region. If you want to just draw a picture, that's fine. Okay. Number 12, we did that one together. This one was kind of the same way, but we were actually solving it. So they want to know exactly 43 boys out of 90 births. So 43 was my X, N was 90. My numbers that I'm going between are 42.5 and 43.5. Calculate both of those z-scores. This is the pain in the butt. Calculate both of those z-scores and then subtract, look them up in the chart, subtract, and we get 7.64. Okay. So that one we did in class the other day. 13, we want to know greater than 6. And this is another one where we're using a normal distribution to approximate the binomial. Okay. So greater than 6 means we're not including 6. We're using 6.5 and beyond. All right. So I'm going to write this out on a bell curve just to make this look a little bit easier. Our average goes there in the middle. So we know that n is 18 and we know that p is 0.3. And our x is 6.5 technically is what we're going to use for x. We're not going to use 6, we're going to use 6.5. And then we need to know the average and the standard deviation. I think maybe that's all that we need. Oh, I guess we need q too. Q is 0.7. All right, so the average is n times p, 18 times 0.3, like 5.4 or something like that. 18 times 0.3, 5.4. Okay, then standard deviation, I do the square root of NPQ. So 5.4 times 0.7, and then I want the square root of that. And that is 1.94, let's say. We'll go 3 decimal places, 1.944. All right, now I want to put on my bell curve, I'm going to put the average here, which is 5.4, and let's see, I'm looking for 6.5. 6.5 and everything to the right of 6.5. So I need to find the z-score for 6.5. So 6.5 minus 5.4 divided by the standard deviation, 1.944. Maybe you rounded to just 1.94. rather than 3 decimal places. So we might get just a ever so slightly different of a number, but that's okay. 6.5 minus 5.4, I could have done that in my head, divided by 1.944, and I get a z-score of 0.57 is what it's close to. And then I want to know from there and beyond. I've got to look it up in the chart. 0.57 is 0.7157, but that is going to tell me from here on back 0.7157. So subtracting that from 100%, 0.2843, I think, or 28.43%. Check that and make sure that that's right. Yeah, that should be right. That should be right. Okay, so something like that. All right, I'm going to go through the bonus with you as well. So it's not technically bonus because we did all these problems together. Here is 0 for z, and they're saying z lives between negative a and positive a, and we don't know what those values are for a. That's what we're trying to find. We're trying to find what those a values are, what those z-score values are. But I do know that in between negative a and a is 0.4314 or 43.14%. Okay, so a couple of you guys did this, different ways, and you totally could. I'm going to do it the way that Colton Wademan was doing it the other day because I really liked his, process, and he did it a lot different than I would have, and his actually made a little bit more sense than mine. So this area in here is 43.14%. Okay, these two areas that are not shaded make up the rest of the percentage. So if I take 100% and I subtract 43.14%, that's going to be 56.86%. So these two regions here add up to be 56.86%. If I divide both of those by 2, or divide 56.86% divide by 2, each one of these is going to be 28.43%. 28.43%. Okay? That's what lives inside of each one of those. So I've got this spread out kind of into 3 separate regions. I've got the 28.43% here. The middle section that's shaded is 43.14 and then 28.43. Let's say that we're trying to solve for this A right here. Okay? We need to find that z-score, and by finding that z-score, you're looking up everything to the left of it in the chart, okay? The area under the curve that's to the left of it is these two regions together. So 43.14 added to 28.43, 71.57%. Or 0.7157. Okay, that's everything to the left of A. So I'm looking that up backwards in the chart. 0.7157, I'm pretty sure comes out exactly. It's like 0.57. So this guy's z-score is 0.57 in the chart, which means the other one is negative 0.57. And that's just one way of solving it. Okay, you could have solved it differently as well, and that's okay, but I really liked this method. Okay, there you go. Test is tomorrow. Study up on this sheet if there's any of them that you missed. Figure out why you missed them. And good luck.